Hi everybody and welcome and hope you have a good lunch. I will today talk about the journey in the country of data access governance. How can we control and handle the data so not wrong people access it, but still people can do what they are intended to do. As we heard this morning, data is the most valuable resource we have in our company today in many cases. So, who am I? I am data engineer. I currently work at Tink, which is a Swedish fintech startup working with business to business. And we say that we are the rails and brains of open banking. We're helping banks to do different tasks around data and machine learning, selling systems for that. But that's not what I'm going to talk to you about today. I will talk about my former work at Svenska Spel, which is the state-owned gaming company. And I will talk how we have implemented our data governance there. Let's start with why in the agenda. Then I will introduce the concept of metadata-driven access control and describe in a theoretical way how it works. A short introduction to Atlas and Ranger. I assume most of you know about it, but let's ensure that everybody has some kind of picture on it. Then going into the more interesting part on how we implemented this. And primarily talking about how we did it within the Hadoop ecosystem. And as a little bonus, this is possible to use Atlas and Ranger outside the Hadoop ecosystem as well. So I will summarize how we did that. And of course, some final learnings and what I brought to Tink. I should not stand there up. So, data access management. GDPR is probably the most common answer to why we want to do this, but there are, of course, other reasons as well. But GDPR pushed quite high pressure on a lot of organizations. I guess most of you have worked around this. It required us to have a clear purpose on why we use personal information. We need to have privacy by design. We need to have clear consent or legal ground to processing the data. We cannot just store data in a pile and say that, well, that can be good for later. And we need to remember that it's the person who owns the data, not the company. And of course, the big buzz about it is penalty if not followed. But this is not the only reason. We have a lot of different other legislations which require you to handle data. We have in the bank world secrecy around data, so you cannot tell who owns a bank account back and forth, how you want to do that. And at Svenska Spel, we also got another challenge. This new year we just passed, we get a new legislation in Sweden on how the gaming market is structured. From a market where Svenska Spel had worked in a monopoly situation, we got legal competition. And that means that we need to follow competition rules as well. And still some parts of our work are monopoly. And that means that we can't let the competitive part take advantage of the monopoly part, since then we will be sued. So we need to be able to handle that as well. So that means we need to restrict our data. And we set up some goals for this. We want to protect our customers' and partners' integrity. We want to follow the regulations of different things. We want only the person that have access to data should have also a clear purpose of it. So you can say that this person has access to this data because he or she is a CRM analytics or some other reason. We want to continue doing the processing we are doing. We want to impact the analysts as little as possible. We want to impact the ETL developers as little as possible. But we need to be able to adapt to new requirements. I mentioned the new regulation of the gaming market in Sweden. When we did the GDPR work, we knew that this regulation will come, but we didn't know how it would impact us. So we had to separate this into two different projects. And we started thinking, how can we do this? One important thing is also that I didn't mention here, but we want to have a single source of truth. Can we have it collected information in one place? So it's easy to understand and say that, well, if you are a business analyst, you have access to this data, you don't have access to this data. First thing that comes in mind is to generate one data set for the CRM analyst, the second for a business analyst, and so on. That will be a lot of data, a lot of duplicated data. That's not feasible. So do the traditional way on adding a view for everybody. But that's not really feasible either, since then you need to remember when you update the view or change the business rules, you need to go into every single view and change this ruling, who's going to see what. So that's a lot of hassle. So take a step back instead. Can we separate the concerns here and say that we want to tag information about our data and say what kind of data there is? Then we will have another concern that says, what policies do we want to apply to the kind of data? We don't care of what data it is. We care about what kind of data it is. Is it personal information? Is it data about our competitive part or our monolith part of the organization? So that's what we ended up in. And that's what I call here metadata-driven access management. And I will here explain how that works in a theory with a concrete example. And we'll come back to how this is implemented a bit later. So this is a normal customer table. We all, I guess, have a customer table somewhere. We have some information that is identifiable of a customer, the name, the customer ID. Other information like postal code is not sensitive in that way. We have a field which says if this person have accepted marketing or not. This was how it looked before we started the GDPR project, basically. And we identify, in this example, two personas. We have one persona that is our CRM analyst. The CRM analyst need to have access to identifiable information, but is only allowed to access the data that are from people that have opted in for marketing. So in this example, the CRM analyst can see Paul, but not anyone else. And the data should be readable and understandable. So in that way, he can send marketing information directly to Paul with a certain message. Then we have another persona that is our business analyst. And he's only interested in how is we targeting our goals, how are we performing, which kind of customer groups are we interested in to targeting to behave better. He has no purpose to know the individual person here. So we can anonymize this information. So let's try to reach these two goals with too much work. First, let's classify our information. In this example, I only focus on the personal information. We have other aspects that you can work on as well. But we identify, we have two columns where we say this is personal identifiable information. That's, for instance, something that we don't want a business analyst to see. We also say that, hey, this table includes personal information. So we know that this is a table we need to do filtering on, so only the CRM analyst can see what's needed. We add this information, and still nothing had happened in our system. It's just metadata. It's a description of it. So take a look on, we're adding a policy here now, the second aspect of this, for the business analyst. The policy is easy. A column that is tagged with PII should be anonymized using some kind of function. So we apply this policy, and finally we have our business analyst seeing this table instead of the identifiable information. The nice thing with this, we only add the policy once. We don't have to add it to every single table, since we have information, metadata about the table and the columns if they are personal information or not. That way, when we change the policy around how we want to anonymize this, we only change in one place instead of in every view that the business analyst is using. We had a second case. The CRM analyst, he or she should only see the marketing opt-in customers. So here we add another policy saying that if this is a table that are tagged with PII table, then you should only see where marketing is true. And voila, we have the result. This is a bit simplified since it's not useful to have marketing in every column with customer information in. So instead, in practice, using a whitelist. I will come back to that a bit later. But take a step back and think about the tags, since that's a fundamental we have here. They have no meaning themselves. We saw that just adding the tags didn't change anything. But it's our business that defines what they mean, and then we add our business rules. So we can define that this business entity is owning this data. I need to talk to them to be able to access the data, for instance. Or I can identify the sensitiveness. This data is sensitive, so I need to take extra care before I'm giving someone access to it. Or I can use it for quality of data. This information can then be used to take decisions on the policies. And that's more easy to reason about than taking a column and discussing around that specific column. Let's take the example of sensitive data. We want to restrict the access of sensitive data. Setting up a policy saying we want to do something around sensitive data is much easier to understand than saying that this, and this column, we want to do something. That's more complex to understand. And we get a disconnection between tables and policies. So quick on Atlas and Ranger. Atlas is our data catalog which collects and includes metadata about our tables or other resources in our Hadoop cluster. A resource can be a column, a schema, a file on HDFS, whatever you want. It can also be, if you want to extend Atlas, a table in your Oracle database. Atlas then collect information, get messages from your Hive system, for instance, saying that now I updated the schema, update your catalog here. You can also get lineage to understand that we transformed from this table into this table. It's in this one we also, of course, add our tags, which is natural since it's all about metadata. Ranger, on the other hand, we often merge these together, but it's important to separate them. Ranger has one purpose, and that's to answer the question, is the user U allowed to do operation O on this resource R? Yes or no? Or yes, but we want you to mask the information or something like that. Of course, it gives us audit logging, so we can track who has accessed what or who have tried to access something they are not allowed to do. We can, with Ranger, set access. We can set filtering rules on each row, and we can set up masking. And we can also refer to these rules with tags, not only with individual tables. And that's where everything starts to come to life. So how can we do this in practice? I talked about the tools. You have seen the screenshots on the user interfaces. That looks good in a demo case, but it's not practical when you have hundreds of tables that you want to ensure are in sync and the changes are happening all the time. It's hard to track this manual editing. It's hard to see what have changed. If someone wants to do an audit and ask me what has changed in the policies between January last year and January this year, I can't easily answer that since some kind of got back and forth and so on, since I don't have version control. And it's also separated from the ETL scripts that I want to deploy. So if someone deploys a new table, I want at the same time the policy to apply. I don't want to ask someone to go into a user interface and enter this. They will forget it, and then we don't have security by design. And of course we have all these other practical things of we need backup of the configuration and so on. So we want to integrate this into a CI/CD deployment system, where we to the right have the ETL developer sitting and editing in a model, in a modeling tool. Oracle Data SQL Modeler was the tool we used at Svenska Spel. Here he describes how the data looks like. It's also at this time he knows what the data is about. It's a good time to set information about personal information. It's set information about quality, owner, and so on. Since it's here, the ETL developer need to understand all that. From this model, we generate, using Data Vault, a lot of SQL transformations, but we also generate information about the tags, so we get a list of tags for each column and each table. This is checked into Git, so we can have version control on it. That means that we can go back and check whatever time back in time we had and see how has this changed. Sometimes we change our business policies, then we need to change our rules. But that's rarely. It's most often when we start introducing GDPR ruling or change our organization, we need to change these rules. So we can, in this repository, also put in our policies. Everything in one place. And we have our Airflow dag.py file that schedules things. And in this we also describe that we want to send these tags that were created and our policies into Atlas and Hive. When committing and saying deploy, Jenkins do some checking and so on. We roll it out and start scheduling on Airflow. And once a day, the tags and the policies are committed and pushed into Atlas and Ranger. We can there also get identification if something has changed. Have someone gone in and changed this manually that was not supposed to do it? Or get tracking that, yeah, we have changed this that was intended. And of course, we do our normal ETL processing. So it's very little we have changed here for our ETL developer. It's only to actually writing down in form of tags the information about the data they anyway need to find out. To be able to do this, we need some kind of tool to integrate and talk to Atlas and Ranger. So we developed a tool called Cobra-policytool, Cobra, sorry. Cobra is the environment name that we use on this environment. So this tool can deploy tags into Atlas. It can deploy policies into Ranger. It's a small command line, so you can easily integrate it into your CI/CD pipeline. We have also extended this tool to some capabilities that we missed in Ranger. For instance, row-based filtering. You can only do that per table in Ranger. But we are very systematic on our modeling. So you always know that a customer table, including customer information, always have a customer ID. Let's take advantage of that when we do our row-based filtering. So we have added capability that we add a filtering rule on a tag and then expand it for all the tables with that tag. We also can ensure that we have the same rules on access for both HDFS and Hive. Otherwise, you have to handle that in manual. The tool is open source, so please check it out. The input to this tool is quite simple. For the tags, a normal CSV file. Don't make it harder than you need to. Starting with schema it's about, which customer, which table, and which attribute. And then a comma-separated list of which tag you want. You can notice that I also included a row without any tags, and that's to be able to handle deletion. So I know a table or a field that's not listed here, I don't know the status of it. Is it listed here without and it has a tag? Then I know I should remove the tag. This is the file for columns, and of course we have the same without the attribute field for tables. Policies are a bit more complicated. So we decided to base this on the format that we were already using in Ranger, since we thought someone have already thought about a lot of things, and let's just adapt for those things we need, instead of trying to create our own language. So we are using this for all kinds of access controls, table access, if we are doing row-built filtering, which also is access, and anonymization for masking. You remember that I talked about the case of the CRM analyst, that we only wanted to see the customers that we had opted in for marketing. Let's look on how this rule can look for a table, or for all tables actually that are marked with PII table. You see here in the middle, it says tags PII table. We are applying rule for every table that is tagged with that. And we say that this is for the group CRM analysts, 2 rows above that. And we're adding a filter condition. checking that is this customer in this whitelist? Yes, then you should show it. We assume that every off table with the PII table tag has a customer ID. That's one of our design rules and business rules. And we use a macro for setting up how we expand in the Cobra-policytool. Each table that we find that has PII table tag, the name is replaced with the dollar curly bracket table. We do the policy to describe some metadata around it, which service you want. It's about Hive in this case. We want to say that it's about a good name so we can find it and track down if anything goes wrong. We want to enable it and we want to make it auditable, of course. And finally, some fields about saying that, hey, this is how you find the database and so on. And this is variables that is expanded automatically by Cobra-policytool. There are, of course, a lot of things that we could filter out here and make it more simple. But we started to working with a very iterative way and just start posting in things into the API for Ranger, and then it grew from there. So it's a little bit too much, maybe worth a refactoring later on. So now we know how to write the rule, we know why we need the rules, but how do I do this in a good way? It can be quite messy. So we started to listing up some kind of like principle that we try to follow. First of all, find a clear business rule. And that means that you need to understand how your business is organized. You will run into cases where someone says that, but I sometimes work with this hat and other times I work with this hat. And of course I know when I'm doing that, the person says, but then you ask them, how do your computer know that? Oh, that's not my problem. And that's an impact how you're implementing this. A systematic data model helps on doing those rules then later on. We decided also that the project creating the table is the one that owns the policies and the metadata around it. This can vary from organization to organization. Like there are other organizations that says that we have this policy department that decides who has access to what, and it should be separated from the developers. Fine. Then we put the policies there, but maybe the metadata should still be. It's up to you. But create a clear principle, who's owning what. Otherwise you will start getting cross-references and it can risk you writing over your own rules and so on. We decided, of course, to have policies on tags. We want to ensure that we are in sync with the rules. We learned that it's quite complex if you don't have access to the logs in Hive to understand what's actually happening sometimes. So ensure that you actually give your users access to this when they are developing things. And of course, always version control. So this was in our Hadoop system. But we have an acceleration layer in form of an in-memory database called Exasol to let our analysts doing fast interactive analysts using Tableau. And ideally, we want the same rules over there to not having to duplicate the data, sending one for the business analyst and one for the CRM analyst. Can we solve this in some way? That's basically the meaning of of Atlas and Ranger. It should be for everything in the organization. And it's also why we have the initiative ODPI that will be some talks later on today or tomorrow about. So, yeah, we can use them in some way. We didn't have all the functionality we needed in Exasol, but we have something that's called virtual schemas. And that means that before some data is presented for the user, we can add some kind of filter and say what we want to do. So we decided to create some virtual schemas. They are written in Python. They can read the data that we have pushed from Atlas and Ranger into Exasol and do the filtering there as well. This means that we can have the same rule and let the business analyst see the data they want to see and the CRM analyst the data they want to see without having duplicate data. And that's the core. And what's that the core in this case is that Exasol you pay per gigabyte you are consuming in memory. So having lesser data in your database, you need smaller hardware, you pay lesser in license fees, and you can use your hardware, of course, better as well. So we reduced the resource consumption on this, which was really valuable. To summarize this, I will take it from the perspective that I just moved to Tink and what do I bring from this project? And I also hope you bring to your project when you need to implement data governance. First of all, single source of truth. Having a clear source where I have the truth instead of having to look in tens of systems is really, really valuable. And also avoiding to jump between different repositories and so on. Have one place is a good thing. Using the policies on tags in front of tables. Yes, please. It's so much easier instead of having to invent the wheel every time I add a new table. I can instead thinking about, okay, what kind of metadata do I need to add here? Automation. When you want to repeat the things, you need to automate. And it's only the only way you can guarantee something is happening. Otherwise, people will forget. We are doing mistakes unintentionally or because we were in a hurry or something. So make sure to automate things so you don't have to do a lot of manual things. Make it simple. It sounds simple. It's not that simple, but it's so easy that someone comes with complex business rules. And as data engineers, analysts, data scientists, or any other role working with data, we are used to think a bit extra about the data. We are used to ask questions to really understand and the need, how we want to use and take decision on these data. Use that knowledge and apply that when building your organization as well. Start asking, is this really making sense? Are we applying the principles we have in our security policy for this? Or to start trying to simplify it. And last but definitely not least, I have many times mentioned that we need to talk to people. People come with strange arguments after a while from our perspective. So bring your business along. Try to tell them what you are doing and why you are doing this and how this can help them. Since it can help them, they don't have to think about, oh, do I need to filter this data when they are adding a query? Since that's also a possibility. And with that, I'm finished, and I hope we have a few minutes for questions, if there are any. Yes?
Can you explain how you use Atlas and the connection to Ranger?
Yes. The question was how we use Atlas in connection to Ranger. So Atlas includes normally just, for instance, schema. And what we used Atlas for is that Atlas has an interface where you can add tags to this schema, and it has this knowledge. So we're using the interface for Atlas to tag the information, which also means that I can easily search for all tables that are PIA tables within Atlas. And then Ranger is consuming this information to be able to handle the rules that we have put into Ranger. So they could be one, but they are separated. I think it's a good decision to have them separated. But most often, I think if you look on the talks saying Atlas and Ranger, it's rarely that you see only Atlas or only Ranger in a talk. So they are very well interconnected, but they have two different purposes. And
about automatic tagging, have you ever tried tools for automate tagging on tables and columns, like outline data or something like that?
can you repeat the question?
I see that you are using Cobra-policytool that lets your developer to define a CSV
Yeah.
in which they define the text for the columns or for the new tables. But I know that there are some tools that allow to automate the tagging.
Okay, yeah.
And my question is, if you ever tried some of these tools, and yes, why you don't use them?
I haven't tried any of the commercial tools that are out there. Some I know, like saying that we can identify a telephone number. Well, they are most often organized to handle American telephone numbers, which is definitely not organized, at least that how we write them in Sweden. But what we do is the tool that is generating the code and the tags, it actually includes some kind of business rules as well. So we do some automatic identification based on column names or types and so on. And now I get told to wrap up. So I will stay around here and ask questions afterwards. Thank you for your interest.